So now we're going to look at problem 5. Problem 5 tells us that the drawing shows a jet engine suspended beneath the wing of an airplane. The weight of the engine is 10,200 newtons and acts as shown in the drawing. In flight, the engine produces a thrust vector T of 62,300 newtons that is parallel to the ground. The rotation axis in the drawing is perpendicular to the plane of the wing with respect to the axis. Find the magnitude of the torque due to the weight and the thrust. Okay, that's kind of crazy. So we focus our main things. I decided to we can just basically look at our drawing to kind of be able to solve this. We write in our known forces. And our axis of rotation is there where we mark the X. Okay, so if we first look at the torque caused by the weight, and we see the distance from the force and the axis of rotation, we can use the formula, which is, the length times the torque times sine, but we need to figure out the angle made by the length from the axis and the actual force. If we draw this triangle, they told us it was 32 degrees, which means if we draw a right triangle, it's 58 degrees, and since the angle is pointing straight down in a 90-degree angle with the horizontal, the angle made by the line of leading to the center of axis and the force is 148 degrees. So we can plug it in 2.5 times 10,200 times sine of 48, and we find out the torque caused by the weight is 13,513 newtons meters. Newtons meters, again, is the unit of torque. I don't believe we put the correct units in the last one. So that you can do that. I typically don't like using the sign because I like using the actual definition of what a cross product is. The cross product is you multiply essentially the perpendicular components. What that means, we can use the components to solve this problem. When the length and the torque and the force are perpendicular to each other, the angle they make is 90, which is sine of 90 is 1, so we can just simply multiply them together without having to worry about the angle. So if we break up their components, we can take we take the length from the radius center, or from the axis, the length from the axis, x component, and multiply it times whatever force we're looking at, y component, and add it to the length of the y times the force x. So we keep multiplying their perpendicular components, and most of the times we don't have to do both because we find out that one of them is 0. For example, the force has no x component. So all we really could do is just find the x component of the distance from the axis and just multiply it by the y. So the torque can be simply written as 2.5 sine of 32, which gives us the length in the x direction, times 10,200, which gives us the force in the y, and we get 13,513 newton meters, which is the same. This one is actually really helpful when you get into very, very complicated problems where there's multiple sides and angles and buildings if we get into that. But it's just a personal favorite of mine. It's the one I'm pretty much going to use for most of these problems. But you could go and use the technical equation of length times radius times sine of what the angle made by the length and the force. So now we can find the torque of the thrust. We draw the little value here. If we use the equation, because the thrust is acting in the x direction, we can just find the distance from the axis in the y direction and multiply it times the force, and it'll give us the thrust. So we can do 2.5 sine of 32 will give us the y component, which is actually a mistake. That should read, there we go. And then 2.5 cosine 32, we make sure that it's negative because if we look at the force, it's going to make the wing move clockwise around the axis, meaning it's a negative torque, so we've got to make sure to include that in the direction of it. Then we multiply it together, and then the torque caused by the thrust is negative 132,083 newtons meters. Done.